Hello, everyone. So we will be solving the question from Code Forces contest. That is latest Code Forces contest. That is Code Forces round 9 and 7 div 2. Find the permutation B. Okay. So let's first understand the question. So you will be given a graph with an vertices. Note it is an untitled graph. Now this graph has a hidden permutation. Means there is a permutation P of size n. Okay. Now what happens is that graph has some condition and it is constructed if for every pair of integers I less than j. Okay, here we need to understand this very important thing. There is an edge is added between vertex pi and pj if and only if pj is greater than pi. Note that the edge is not added between the vertices I and j but between the vertices of their respective elements, means pi and pj. So now let's understand the question. Means we need to construct the permutation P and it is always unique. Let's understand. So in the question we have been given the graph. Now from this graph we need to create what? A permutation 1 2 3 4 5 of length n, that is the number of nodes. How? Understand, here we have been told for every pair of integers I less than j, means we need to consider this pairs 2 comma 3 3 comma 5 1 comma 4 all having satisfying this pairs, and means I and j are indices, means to see this one index and to this second third fourth. Okay, to see this indices, to see this indices, to see this indices, to see 1 5 and to see 2 3 2 4 2 5. Now see here if pj in the permutation I find at pi, means pj will be, let's say, here and pi is here. Okay, because it is the same thing. We have defined I and j in such a way that j is greater than I, means pj will be after from pi. So here we need to understand that, okay, if I found pj greater than pi, means there must be an edge between them. Here the 4 and 5 are pi and pj. Understood? Means what? See here there is an edge between 4 and 5. Here, as pj is greater than pi, means this is pj and this is pi. Okay, this is pj, this is pi. Now what it means is that in this permutation, as I is less than j, that means that 5 have been come after 4. Means this 5 can be here, but for sure it will be after 4. That is what the question means from pj is greater than pi having I less than j. This 5 is pj and this is pi. Let's see this one too. Let's see this 1 2. 1 2 means is that pj is 2 and pi is 1. That means as I is less than j, means 1 2 will come after 1. Here. Okay, 1 and 3, that also means same thing. 2 and 3 also means same thing. 2 5 means 5 will come after 2. Okay, 3 5 means what? 5 will come after 3. We have no, okay, this element will come after that. Okay, now now we have understood the question, but how we will approach it? Let's see it. Okay, now see here we have here we have 4 to 5. Okay, 4 to 5. Okay, how we will decide permutation? So see, this, okay, so these are our edges 1 2 1 3 2 5 2 3 2 3 4 5. 4 is a 3 5. Now see here one thing. See here, can I determine the position of 1? Can I? How? See, I know that, okay, my 1 is having an edge with 2 and one is having an edge with 3. Now this is our pj, this is my pj, and it is always my pi. I know that, okay, this I of 1 is less than 2j, is less than with 2j, is okay, sorry, 3, okay, my bad. There's an edge between 1 and 5 also, my bad, sorry, yes, 1 3 2, so 1 5, okay, I'm sorry, it's not 1 5, it's 1 2, it's just not there, okay, sorry, so here is 5, but I need to tell is that there are 2j, let me make it clear, there are 2j, okay, there are 2j which are having edges and which are pj is greater than pi. That means it is sure that my 1 is that there are, after 1 there are exactly 2 elements. I'm sure by seeing this thing, means I'm sure that my 1 will be kept here. That is sure here 3 and 5. How, I don't know, I will figure it later out, but my 1 is fixed. 1 is fixed. Let's see about 2. Let's see for 2. 2 is having an edge with what? 2 and 3. Same, 2 and 5. Okay, great. Now here was 1. But again, if I see, okay, there are 2j, that 3 and 5 for same for same I2. 2 should come here then. But I can't put 2 here. No, there is 1. What should I do? Can I put here 2? Yes, why not? Because if my j has less value than my this I, there is no edge. There won't be any difference because pi is greater than pj. So there is no edge between 2 and 1. So you can go to left if it is smaller, and it is how we are approaching. Now let's see next thing. Next is what? 3 and 5. See, 3 and 2 and 3 and 1 doesn't make any sense. I just need to count the edge, the nodes which are greater than 3. That is 1. That is 1. Means 3 would have come here, so that there is an one element that is greater than 3. Now we can see 4, but it's good to see here. Now, okay, now see, now here is the catch. Here is the main thing to see. Okay, here is the main thing to see. What is that main thing? Okay, so here we have 4, here we have 4 and 5 edge. Okay, 4 to 5 edge, right? 4 to 5 edge, right? Now that 4 to 5 edge, it means is that 4, there is a one position that is greater than 4. Okay, so 4 should have come here in the place of 3, but there is 3 already. No problem, go back. There is 4. No problem, go back. There is 2. No problem, go back. Come here. Place here 4. Because this 2, this 1 and 3 will not make any difference because they are smaller than this 2, 1, 3. And we have for 4, there is a greater element that will come after it, and I have left that 1 position. And as you can see, the 5 has all the elements, that is 4, 1, 3, 2, but they are not greater than 5. Okay, so 5 should be placed here. Understood? Okay, now let's see something. Let's say here, this is our permutation, and let's say these are my field. These are my field. Okay, these are my field, right? And I got the n element that I need to place in that with the greater node count of 5. So where should I place my element? See, I got 1 empty, means afterwards the larger element will come here. I got second empty, it will come here, count of 2. This is third position, it will come here. This is fourth position, it will come here. This is fifth position, fifth larger element will come here. And this is my position of my element. This ensures that this smaller element, there are no edges between this smaller element, but this count of 5, this 5 ensure that there is an edge between them because they are empty, and this empty will be filled afterwards, because I'm going from 1 to n. I'm going from 1 to n. Okay, so the basic algorithm is to start with 1. Okay, to start with 1. So this was our graph. Okay, 1, 3 and 2. Okay, and start and see. Okay, 1, how many it's having an edges? 2. Okay, so and how we have to go left side, empty positions. Okay, so I will initialize my array with -1 to denote that okay they are empty positions. Okay, and I will then keep placing the values. I saw okay 1 and 3 are 2 edges, come to count of 2 -1, here not, and here will place. We will then see for 2 are having 2 and 5, 2 5 and 2 3. Okay, go for it. 2 will be here, but there is no place here because 1 is placed, so put 2 here. Ask for 3, 3 to 5. Only count that nodes that are greater than 3. Okay, that is 3 and 5. So one left of -1, that is here 3. Then comes 4 and 5 edge, 4 and 5 edge. 4 come here, but here it is not -1, not here, not here. Yes, here is my -1 after one element. Okay, and here will come 5 because there are no elements. Okay, so now let's get to the code and understand the solution in. Okay, so and please note here one thing, that not every graph will have permutation. So in the question, in the test case, it is ensured that the only graph will be given to you which can have this permutation. Understand? Okay, so here we need to take care of one thing. Here these are string. Okay, so take in that way. So as it is n cross n matrix, we need to go for n rows. Okay, so I take a string as input here to get my first row. Okay, so I got my first row here. Okay, and I initialize my adjacency matrix. Okay, with array. Okay, and here. Okay, so j equal to 0, j less than n, plus I know because there are n elements, and do what it is adjacency of ij that is equal to s of j minus 0. If s of j will be 0, then 0 character minus 0 will be 0, and if s of j is 1, then it will be 1 character minus 0, that is 1. Okay, so I have created my adjacency matrix. Let's create my permutation. Initialized it empty by initializing it with -1. Okay, great thing. Now let's start. I told you we will start from the smaller element. It is I equal to 0. Here, as I am taking I equal to 0, as my permutation is 1 based, I am just for taking care, I am doing the code with 0 based, and when the insertion, at the time of the insertion, I will insert I plus 1. Okay, I will insert in the permutation I plus 1, but because my adjacency matrix is 0 based, I will do with I. Okay, I equal to 0. Okay, now what? Okay, so I will count all the edges that are greater than I. Okay, I will count all the edges with the nodes that are greater than I. Okay, so initialize my count, greater count, g count equal to 0. Okay, and for what I told you, for j that are greater than I. Okay, this will take care of that. Okay, and if there is an edge, so for the checking the edge, the adjacency matrix value should have value 1. Okay, understand? Okay, equal to 1, then do count plus g count greater count plus. Now iterate from right. We need to iterate from right here, right? We need to iterate from right, and then check if my count, if from left side I have passed 2 -1 or 2 empty places, then I can put my element at the position of -1. Okay, so I iterate from left, k equal to n -1, k is greater than or equal to 0, minus k. First thing, first thing to check if my per of k equal to minus 1, and then what, count equal to 0, means this is my perfect position to place. Here if I see perm of k equal to minus 1 and g count, which was what, which was here, g count is 2, here will be 1 after 1, here after this loop, when the loop will come at this iteration, my g count will be 0, right? So if g count equal to 0, then what, initialize my perm equal to k equal to with I plus 1, because it is 1 based, and break the loop. Or else do what, else means there are two cases. That means if this is not minus 1, then we need to find the element. But if my g count is not 0, then only do minus if only when if perm of equal to minus 1. Okay, so my here I will do what, g count minus. Okay, because I told you here that only empty places, we have to go left from empty places only. We don't want to do minus of g count if I don't found my perm of k equal to minus 1. Okay, so and finally I will print my array. Okay, so let's run and check if it's working fine or not. Let's run and check. Okay, so there's a syntax error. Okay, so yes, it passed. So if you have any doubts, you can ask in the comment section. Thank you.